Lesson number 15, Fun with Magnets. Question number 1, fill in the blanks with appropriate words. First, if a bar magnet is hung by a thread tied at its center, its north pole becomes steady in the direction of the north pole of the earth. Second, if a bar magnet is cut into equal pieces by cutting it at a right angle to its axis at two places, 3 bar magnets are formed and a total of 6 poles are formed. Third, there is a repulsion between the like poles of a magnet and attraction between its opposite poles. Fourth, when a magnetic material is taken close to a magnet, the magnet acquires induced magnetism. Fifth, if a magnet attracts a piece of metal, that piece must be made up of magnetic metal or iron. Sixth, a magnet remains steady in a north-south direction. Second, write whether the following statements are true or false. If false, correct and rewrite them. First, the poles of a magnet can be separated. False. Second, the magnetic force is not concentrated at the two ends of a magnet. False. Third, scientific discoveries should be used for the good of a mankind. True. Fourth, after hitting the magnet, its magnetism increases. False. Fifth, electromagnetism is permanent. False. Sixth, magnetism is a kind of energy. False. Corrected statements. First, the poles of a magnet cannot be separated. Second, the magnetic force is concentrated at the two ends of a magnet. Fourth, after hitting the magnet, its permanent magnetism doesn't increase. Fifth, electromagnetism is temporary. Sixth, magnetism is not a kind of energy. Question number 3, how will you do this? First, determine whether a material is magnetic or a non-magnetic. Answer, move magnet over it. If it sticks, then it is a magnetic, and if it is not, then it is a non-magnetic material. Second, explain that a magnet has a certain magnetic field. Answer, place a white paper on a drawing board and place a bar magnet in the middle of a paper. Spread the iron fillings on the sheet and gently tap the sheet. The iron fillings arrange around the magnet in definite curved lines, forming a symmetric pattern. The lines are closer to each other near the poles and less crowded in the middle region around the magnet. Third, find the north pole of a magnet. Answer, take a bar magnet, tie a thread to the center of the bar magnet and hang it from a stand. Note the direction in which the magnet settles and turn it around again. The end of the magnet that points to the north is called the north pole, while the end that points to the south is called the south pole. Question number 4, which magnet will you use? First, iron to be separated from trash, electromagnets. Second, you are lost in a forest, bar magnet. Third, a window shutters open and shut continuously in the wind, bar magnet. Fourth, the doorbell should ring, electromagnet. Question number 5, write the answers in your own words. First, write the properties of a magnet. Answer, first, magnet always settles in north-south direction. Second, the magnetic force is concentrated at the two ends or poles of a magnet. Third, if a magnet is divided into two parts, two independent magnets are formed. Fourth, a magnetic material acquires magnetism when placed near a magnet. This is called induced magnetism. Fifth, there is repulsion between like poles of a magnet, while there is attraction between the opposite poles. Second, how is an electromagnet made? Answer, a magnet is prepared by passing an electric current through an insulated wire wound around the iron nail. This is how an electromagnet made. Third, from which metals are permanent magnets made? Answer, permanent magnets are made from a mixture of first, nickel cobalt iron, second, aluminium nickel cobalt alnico. Fourth, what are the practical uses of a magnet? Answer, first, permanent magnets are used in caps of a pin holder, doors of fridge, doors of cupboard, etc. Second, temporary magnets. Electromagnets are used in electric bells, circuit of various machines, ATM, card swipe machines, MRI, loudspeakers, electric cranes, microphones, etc. Fifth, What is a magnet keeper? Answer. For the protection of a magnet, a bar of a soft or a pure iron is kept along with a magnet in the box. This bar protects the magnet and is therefore called a magnet keeper. 6. How does a maglev train work? Answer. First, maglev train works on the principle of electromagnetism and repulsion between the magnets. There is a repulsion between the train and the rails because of the electromagnets which are fixed. Second, train slides over the rails with a great speed. There are magnets fixed on both sides which help to move the train forward.